What's up everyone? Welcome back to Tech Nexus. Today, we are taking a deep dive into what might be the biggest AI curveball of the year. A robotics clip started spreading online recently, and the moment engineers saw it, they realized something massive was happening under the hood. The clip showed a humanoid robot walking through a room, scanning everything with LiDAR and cameras. Now, robots building maps to dodge furniture is not new. They do that all the time. But here's the twist. The system running behind it, called OpenClaw, turns everything the robot sees into a real memory of the world. Space, objects, and time all get linked together. Every movement and every object becomes part of a structured record the robot can search later. It is not just navigating a room anymore. It is actually remembering the world it moves through. The developers call this capability spatial agent memory. Traditional robots mostly operate in the present moment. They look at sensors, react to what they see, and the context of earlier events fades away quickly. But with OpenClaw, if a person walks into the room, the robot registers exactly where and when it happened. The machine gradually builds something that resembles a timeline of the physical world. The team pulls this off using a concept called voxels. Imagine dividing physical space into tiny cubes like three-dimensional pixels called voxels. Instead of storing the environment as simple, flat images, the robot stores geometry and meaning inside every single cube. Over time, it builds a massive layered structure containing rooms, objects, surfaces, positions, and timestamps. That structure becomes the robot's spatial memory. Because of this, you don't have to rewind a video feed like a security camera. You literally ask the robot, "Where was my set of keys last seen?" The system searches its spatial memory for the object labeled as keys and returns the most recent location. You could ask, "Who entered the house on a specific evening?" Or "Which room do people spend the most time in?" The robot analyzes spatial activity over days or weeks to give you the answer. It is querying a structured model of the world. This difference is exactly why the demo triggered such a strong reaction online, with some people joking that someone had basically open-sourced Skynet on GitHub. But the flexibility of OpenClaw is what makes it truly groundbreaking. It runs independently of specific hardware. You can run this software stack on humanoid robots, quadrupeds, drones, or theoretically even by hooking up sensors from a smartphone. It perfectly separates the high-speed motor control from the deep-thinking AI layer, letting the robot move quickly while still building a long-term understanding of its surrounding. What is even crazier is that developers are already connecting OpenClaw to real machines right now. In one widely shared experiment, they hooked it up to a $16,000 unit G1 humanoid robot. Instead of writing complex code, users can control the robot through simple text messages on apps like Telegram, Discord, or WhatsApp. You just text the robot to move forward 1 meter or turn left, and it executes the movement. They even connected it to a 3D printed robotic hand, and the AI used visual feedback to calibrate itself and eventually make a peace sign. At a larger scale, developers are even giving these machines decentralized identities on blockchain networks. That means a robot can hold funds, execute transactions, and participate in machine-to-machine payments all on its own. 2026 is truly starting to look like the exact moment AI agents begin interacting directly with reality. While robots are getting physical memories with OpenClaw, the software world is experiencing its own massive earthquake. Let's talk about OpenAI because they just dropped something called Symphony, and the big idea here is absolutely wild. Until now, we have used AI to help us write code, maybe fix a quick bug or generate a specific function. But Symphony flips the script entirely. Instead of asking an AI to assist you, developers can now send AI agents to do the real coding jobs entirely on their own. Think about how software teams normally work. You have a long list of tasks and an issue tracker, things like bugs that need fixing or new features that need building. Usually a human developer looks at that list, picks a task, and starts coding. Symphony changes the game. When a task hits a status like ready for agent, Symphony automatically activates and sends an AI worker to complete the mission from start to finish. Before the AI even touches the main code, Symphony creates a separate workspace specifically for that task. You can think of it like giving the AI its own completely isolated laboratory. Whatever the agent does stays inside that environment, so there is zero chance of it accidentally breaking the rest of the project. Inside this lab, the AI reads the task description and gets to work. But here is the most impressive part. Symphony does not just blindly trust the AI. The agent actually has to prove that its code works. Before any changes are accepted, the AI must produce a proof of work. It runs its own automated tests, generates reports, and even writes a walkthrough explaining exactly what it changed. Only when all of that checks out perfectly does Symphony move to the final step called landing, where the AI submits a pull request, just like a human engineer would, to make sure the AI knows the rules. Its instructions are stored directly inside the code repository in a file called workflow.md. This file acts as a strict contract. It tells the AI exactly how it should behave and interact with the codebase. Because it lives with the code, if the project changes, the AI's instructions change with it. And to keep things running smoothly, OpenAI built Symphony using Elixir and the Erlang Beam runtime. This is huge for reliability because AI agents can sometimes fail or get stuck. The Beam runtime is famous for handling massive numbers of processes at once, meaning Symphony can run hundreds of AI coding tasks simultaneously without the entire system crashing if one single agent fails. OpenAI calls this a scheduler and run, basically the ultimate middleman between project management tools and the codebase. It is completely redefining what it means to be a software developer right now. While OpenAI is trying to turn AI into a full-time software developer, Xiaomi is experimenting with something that hits much closer to your everyday life. They just launched a system called Xiaomi MiClaw, and it is basically an AI agent that lives deep inside your phone's operating system. Normally, AI assistants run inside their own little separate apps. They can answer questions or search the web, but MiClaw goes way deeper than that. It runs at the system level, which means it has total access to the phone itself, your apps, your system settings, and even your connected smart home devices, driven by their powerful MiMo large model, which reportedly rivals DeepSeek v3.2. This AI does not just answer questions, it actually operates the phone for you. Imagine telling your phone, "I will bring my friend home in 30 minutes. Prepare the house." The AI understands the goal and starts doing things automatically. It adjusts the lights, opens the curtains, and changes the air conditioner temperature. It connects directly with over 1 billion devices in the massive Xiaomi smart home ecosystem. But how does it actually work? Xiaomi uses something called an inference execution cycle. The AI gets your instruction, decides which of the 50 system-level tools it needs to use, and executes them step by step. You can actually watch this process happening in real time on your screen. To make sure the AI does not forget what it is doing during complex tasks, Xiaomi built in the 3-level context memory system. But the real magic is how it understands your personal context. With your permission, MiClaw reads information from your text messages, calendars, and usage patterns. If you get a text about a train ticket, the AI recognizes the travel info, automatically updates your calendar, sets reminders, calculates your departure time, and links everything together. It even handles your finances. If it looks at your bank, text messages, and spots the different video platforms charging you for similar content, it might recommend canceling one, literally saving you money. And for those worried about privacy, Xiaomi says most of this data is processed locally right on your device. The cloud only gets the current request and deletes it immediately. What is even crazier is the self-evolution system. MiClaw can actually create savages, which are tiny AI assistants specialized for different tasks, like one for your schedule and another for your news. It can even run basic programming scripts directly on your phone, with third-party app support and a context protocol that connects to your computer. Your phone is no longer just a device. It is an autonomous, digital butler that learns your habits and runs your life. Now, while OpenAI and Xiaomi are focused on AI that takes action in the real world, Microsoft is solving a completely different problem. They just released a brand new model called Phi-4 Vision 15B, and the strategy here is brilliant. Right now, every other tech giant is trying to build massive AI models with hundreds of billions of parameters, but Microsoft went the exact opposite direction. They built a compact, highly efficient 15 billion parameter model that is an absolute beast at understanding both images and text. The core idea behind this is actually really simple but genius. Microsoft realized that when AI fails at a complex task, it is usually not because it cannot think. It fails because it cannot see properly in the first place. If an AI misreads a messy screenshot or a complicated document, its reasoning is already doomed from the start. To fix this, they combined their FAI for language model with a powerful vision encoder using a design called MIDI Fusion. This setup gives the AI a dynamic resolution vision encoder that can process up to 3,600 visual tokens. In plain English, that means this AI has incredible eyesight. It can look at complicated handwritten math equations, dense technical charts, and crowded user interfaces on your screen, and understand exactly what it is looking at. And here's where it gets really smart. Microsoft trained this model using something called mixed reasoning training. Only 20% of its training forced the AI to think deeply about complex math or science problems using special think tags. The rest of the time, it was trained just to perceive things quickly, like reading text from an image or finding a specific button on an app. Because of this split training, the AI knows exactly when to stop and think deeply, and when to just react fast. Microsoft says this makes it the ultimate computer use agent. It can literally look at your screen, understand the interface, and help automate actions on your computer or phone without needing massive computing power. It is a massive step forward for making powerful AI small enough to run efficiently everywhere. When you look at all of these massive breakthroughs together, 2026 is clearly shaping up to be the exact moment when artificial intelligence stops just chatting with us on a screen and starts directly interacting with reality. We are moving away from AI that just generates text and entering the era of AI agents that take real-world actions. Whether it is OpenClaw giving physical robots an actual memory of the world, OpenAI Symphony writing and testing entire software projects completely on its own, Xiaomi MiClaw acting as a digital butler running your smartphone and smart home, or Microsoft Phi-4 Vision giving AI the perfect eyesight to read and interact with your computer screen. The leap forward we are seeing right now is just absolutely mind-blowing. The machine economy and autonomous agents are no longer science fiction. They're already here. But what do you guys think? Are you excited about robots gaining spatial memory and AI basically operating our everyday devices? Or do you think this technology is moving a little too fast? I would love to hear your thoughts. So let me know down in the comments below. If you want to stay ahead of the curve and keep getting these deep dives into the latest AI and tech updates, make sure to smash that like button and hit subscribe to Tech Nexus. It really helps out the channel, and it makes sure you never miss a massive update like this. Thanks so much for watching, and I will catch you in the next one.